This is 1.6 student notes, solving right triangles. Okay, we are going to be using our calculator on this lesson, so make sure you have that out. Okay, we are going to be using SOHCAHTOA as well, and using this right triangle right here. Remember, when you're setting up your right triangle, the big letters go on the angles, and then the small goes across from the angle. Okay, when setting up this triangle, I'm just going to redraw it real quick. This is B, C, and A. Okay, filling in my missing information. This is going to be 5, and angle B is going to be 38 degrees. Of course, finding angle A is going to be my easiest one, so the measure of angle A is going to be 90 minus 38, so this is going to be 52 degrees. That's one of my missing sides. It says find the missing sides and angles of everything. So the degrees of the angles are going to be rounded to whole numbers, and then the sides are going to be rounded to the nearest thousandth. So 3 places, just like always. Okay, in order to find A, my missing side, or little c, let's go ahead and find A first. Okay, to find A, looks like the easiest thing to do would be to use tangent. So tangent is going to be opposite and adjacent. Remember, I said I'm going to use SOHCAHTOA. So I'm going to set up tangent is going to be of 38 degrees. Tangent of 38 degrees is opposite over adjacent. So 5 over A. And then we just need to solve for A. So A is going to round to 6.400, and that's going to be 3 decimal places. Okay, let's try little c. If we want to use C, again, you could use A, but I'm going to stick with everything that I know is for sure. You can use 38 degrees, or you could use 52, because, of course, that's a give me. So in order to find C, that's a hypotenuse. So you could use sine, or you could use cosine. So I'm going to use 38 degrees, and I'm going to use opposite and hypotenuse, so that would be sine of 38 degrees is opposite and hypotenuse, so that's going to be opposite and hypotenuse. So again, solving for C, C is going to be 8.121. If you're having trouble understanding how I'm solving for these sides, make sure you're asking in class. Okay, I'm using the same triangle over and over, so I'm just going to redraw it so it's easier to see each of my information. And if you notice, I'm never going to build off of my C, so I'm never going to do sine or cosine or tangent from C. All right, so little a is going to be 4, and little c is going to be 15. So I don't have an angle given at all except for my 90 degrees. So let's go ahead and find little b, and you can use Pythagorean from that, which would be really easy. So 15 squared minus 4 squared gives you your unknown. And this is going to be approximation. It's going to be 14.457. And this is AC. All right, now in order to find A and B, we're going to be using our information from our previous lesson. So we're going to be using arcs. So it just depends on what we want to find next. How about we find the measure of angle B? Just because. So the measure of angle B, in order to find that, it looks like we have both the adjacent side and the hypotenuse, so it looks like we're going to be using cosine. So I'm going to say cosine of B is the adjacent over hypotenuse. So in order to solve for just B, I'm going to move my cosine over, which we now know in order to solve for that is an arc. So that's going to be arc cosine of 4 over 15. So make sure you have that in degree mode. Plug that into your calculator. And the measure of angle B should be 75 degrees. Now I could have started with A as well. I just started with B just because now you can find the measure of angle A really easy by saying 90 minus 75, and that gives you 15. All right, let's try number 3. Draw my triangle of what's given. Remember, this is C, B, and A. So C is 23.6, and the measure of angle A is 24. So we can find the measure of angle B really easy by saying 90 minus 24. So the measure of angle B is 66 degrees. And then we need to find all the other sides. So how about we find A first? In order to find little a, it looks like we can use sine of 24 by saying opposite over hypotenuse. So sine of 24 degrees is A over 23.6. Remember, solve for A. And I got 9.599, rounding to your thousandths place. Okay, from there you could use Pythagorean if you wanted to. If you do, make sure you're not rounding to the very, very end. I think it's easier to go ahead and use SOHCAHTOA myself. So I'm going to go ahead and find B by using sine from this angle. Why not? We know this is 66, so I can use sine using opposite over hypotenuse again. So this is angle B. So I can say sine, just to show you all a little bit different way to do it. Sine of 66 is B over 23.6. So it looks exactly like this angle. Multiply, and you get angle B, or I'm sorry, side B is 21.560. Now if you use Pythagorean, you're going to get a slightly different answer, but it's still going to be very, very close. Okay, now on this one it says draw a diagram and solve. Round side measures to 3 decimal places and angle measures to the nearest degree. So according to a safety sticker, a 20-foot ladder, on a 20-foot ladder, the distance from the bottom of the ladder and the base of the wall in which it leans should be 1/4 the length of the ladder. So that's 5 feet. So we basically have a wall here, and we have a ladder leaning against it. And our ladder is 20 feet. And then the floor is 5 feet. So it's 5 feet off of that. Of course, that's going to be 90 degrees. We don't know how high up it is. Okay. On A, it says if the ladder is in this position, what angle does it make with the ground? So we need to find theta here. And then B says how high up is it? So let's find A first. So A is looking for theta. So if we're looking for theta first, how about we use cosine? So cosine of theta is going to be adjacent over hypotenuse. So if we solve for theta, that's going to be arc cosine of 5 over 20. And of course you can reduce 5 over 20. It's not going to make a difference. Plug that into your calculator in degree mode and you should get 76 degrees. On part B of course is how high up the wall it is. You could use Pythagorean to see this right here. 20 squared minus 5 squared is equal to your x squared. And that's going to give you approximately 9.36 feet. Or if you would like to use a trig function, I would use tangent since you're looking for x, and you could use your 76. So that would be tangent of 76 degrees is equal to x over 5. And x is going to give you, of course, 19.36 feet. Either one is appropriate. It's totally up to you. Okay, so now angle of elevation and depression. An angle of elevation or depression is always formed by a line of sight. That means when you're looking out, let's see, if you were looking out right here, it says it's formed by a line of sight right here, and a horizontal line. So out here, horizontal line and a line of sight. So there's your angle of depression or an angle of elevation. Okay, an angle of elevation or depression will never be formed by a vertical line. Never. Okay, when you are looking up at an object, an angle of elevation is formed. When you are looking down, an angle of depression. Okay, so here's your depression because you're looking down, and here's your angle of elevation. What's so special about these is that they are congruent. And why is this true? If you can picture this picture from way back when, if you have parallel lines, and you have this line right here, this is called a transversal. This right here and this right here, this would be your depression and this would be your elevation. These are called alternate interior angles. And this is from geometry, and these are congruent, alternate interior angles. Okay? So if we have a flagpole cast a 60-foot shadow when an angle of elevation of the sun is 35 degrees. Now, I have some people that have a hard time with this sometimes. So here's your flagpole. It cast a shadow. Remember, your shadow is on the ground. It's 60 foot. An angle of elevation of the sun. Well, here's your triangle. Of course, the sun is up here, okay? Where's an angle of elevation? Elevation is always up, looking up. So your elevation is down here at 35 degrees. And I know that's the strangest part because I always want to put the elevation up here. The shadow is down here. Find the height of the flagpole. So we want to find this. So I'm probably going to use tangent, so I can use opposite over adjacent. So I'm going to say tangent of 35 degrees is opposite over adjacent. You can solve to get x is equal to 42.012, and that's going to be feet. Anytime they don't tell you what to round to, go ahead and round to the thousands, which is 3 places. All right, a guy wire, and if you don't know what that is, think a wire. Needs to be used to stabilize a radio antenna. The antenna is 20 meters tall. Okay, so here's my antenna. It's 20 meters tall. And an angle of depression from the top of the antenna. So remember, depression is straight out and down. So here is my depression right here. The antenna is 20 meters tall, and the angle of depression from the top to the point where the wire connects to the ground is 23. So let me undo the star. That's 23 degrees. Okay, so this is where it touches the ground. This is my wire. How long should the wire be? So this is my wire. Now remember, because these are alternate interior angles, if this depression is 23, so is this. Okay? If we want to know how long the wire is, you can ignore this 23 if you wanted to, or you could subtract from 90 and find this angle. I'm going to use opposite over hypotenuse, so I'm going to use sine of 23 degrees is opposite over hypotenuse. Solving for x, I got the wire is 51.186 meters long. Okay, if you have any questions, please bring them to class.